drag strut of the landing gear, and this whole system will help when landing gear to come out from the airplane body, or if we take call it in technical language, it's called erection of the landing wheel. Erection during landing and taking back into the body while it take off. Like this, it is joined here. This is drag struts our drag strut 1 and drag strut 2. Here it is the pneumatic cylinder and pneumatic piston. The cylinder is joined to the body and piston joined to the drag strut. Like here, this small part is that system. This is whole system, pneumatic system, which is used to erect the landing gear. This here is a ball joint. It moves like this upward, and this help to take out. So let's start making this. Yeah, it's a very simple design, a road, and here it is a joint for drag strut. Here avion will come, and this cylinder is put. This piston is put it into this cylinder from lower side. So nowadays we are making these landing gear parts. Let's start doing per day one or maybe two, and someday we will also make two parts where which part needs less time to make. So let's start making piston. Yesterday we have done pneumatic cylinder, and before that we have done torsion link. And torsion link, this was the torsion link. I will show you. This is the torsion link. It is connected here. These two. One is to the piston and one is to the cylinder leg, and it avoids turning and twisting of the landing gear. From front side you can see this like this here. Okay, now let's start our today's class, that is piston, pneumatic piston. This one. Let's start. Create new object. Here we have to make a part, that is part design. For a part there would be a body. Let it open, taking like more time. Yeah, create body. You can take it from here and also here. Both are same thing. I always take it from here. And body would need a sketch to make. Create sketch. This is top plane, XY plane. I am taking top plane only. Okay. Here I will make a circle to make that piston cylinder. Sorry, piston cylinder only. This is free to move anywhere. Has 3 degrees of freedom. So I will fix it so that it don't have any degree of freedom. It we are not in a position to give any freedom to these over sketches. Now still 1 degree of movement because radius is not fixed. It can be anything. So fixing its radius also. This let it be 29, as we have taken piston cylinders dimension be 30. So you can also take 30 or 29, anything, because all the dimensions are interlinked. But I remember those dimensions, that's why I am taking 29. In further parts I will take any dimension because we are not going to assemble them close. Now make it isometric. I will pad it. Pad means making a sketch into a solid by adding material. That was, I think, yesterday we take 200 length, let it be 150 symmetric in nature. Okay, zoom to fit. Here it is. It is not looking cool, so let me change it to 250 and that was I guess 300 so that it looks nice. Done. Here we got this part, this portion, this length. Okay, now what next? We need to make this, and this is not hollow, so this is complete. No need to add anything or now create another body. Okay, I'm making it so fit for body. I need a sketch. And sketch would be in exact plane. Okay, here. Now here we need a sketch. This sketch is like this, a bit longer from all the sides. I'm making I'm making this now uh, at the bottom of the piston. Yeah, let me take this one, that is polyline. This part is free, so I'm fixing it with this. Okay, I'm taking an horizontal line, make it horizontal and vertical. These two are vertical. Now even these two would be equal to each other. Done. Like this. I have to place it here, making dimensions from here to center. That we take 250 by exactly here. Now I'm taking it a bit way. This one. What was our radius? 29. That is diameter would be around 58. Okay, 58. So it could be 100, 25, 25 both sides. This is 50. Okay, this length is 100. You can also, I'm taking it up only. So just not take. Let me give this length to not to give only one. It would be 50 only. Now what next? I'm going to take and center arc from here to here. Okay, making these two tangent and also these two tangent. Now these are free to move. Okay, I am fixing these points and points. This point and this point. Now it is fixed. Now it would be moving. First, I will remove this tangent so that I could get these 2 points. I am making them coincide. Okay, like both the points coincide. No more dimensions are required here. Now this is tangent and these are equal. So this is the here I need a single circle. Here this. Okay, I will fix its center with the let me give its radius 26. Let it be 26. Now make these 2 points coincide with each other. Coincide. Now it's all fine. I can close this and pad this one too. Will be symmetrical. How much? Up to any distance. Let it be 120 only. Done. I will make it soon. Okay, here it is. Now you know what we need. We need only this thickness and this thickness. This part is hollow. So on this face, I will sketch. Okay, the sketch would be a rectangle from here to here. Okay, we need to give dimensions. It was I guess 120. So let it be 100. 10 mm both the sides would be enough. This any dimension we don't care about it. Okay, we care about this dimension. That would be 50. 300 and 10 50. Okay, now again one degree of freedom. That is this thing. Let it be 155. Would be enough. Close. I guess we take this as much cut through all that. Okay, I will like to see it from here. You can see this. I have done this completely. got the that you here the problem is that's why I was just saying this. I have taken a wrong dimension of that sketch. Related one. I guess it will solve the problem. No, a bit more less 145 is fine. Yeah, it is fine. But if we take a little bit more of, then it would be more fine. That would be 140. And I want to decrease this distance to 80 and this to 40 close. Yeah, now it is much fine than previous one. Like this. This is our pneumatic piston, which will go inside that pneumatic cylinder, and here it would be joined by the with this row struts, drag struts. Here we got it. It was too easy and simpler one to make or design. All rather this thickness, all the dimension would be dependent on other parts, and other parts dimension would be dependent upon the requirements. Now you can see this body 2 and body 1 are different. I will apply a boolean so that it would make a single body. Boolean this body and add body. Wait a minute. Body 1 boolean add body 2. Okay. Now boolean देखो. The whole body is considered as a single body, and previously it was two bodies, 1 and 2. This as we made two bodies, and that's why it was 2. Now applying boolean and addition boolean so that these two bodies are considered as one. When a designer or a drafter would look it as a drafting sheet, he will consider these two bodies as a single body, and so from that drafting sheet a manufacturer or a will make it as a single body. Otherwise this would be two bodies and they will make two separate bodies, and we have to join them. This boolean operation is important while for manufacturing at industrial level. So whatever a drawing will say, a drafter will make that, and from that drafting sheet a machine or a manufacturer will make make parts. So if we need a single body, we have to apply boolean in two bodies so that they will consider this as a single body and make it as a single part. That's all for today. Thank you. I know this lecture was a bit shorter because of the parts complexity. It was not a complex part, it was simple and a short part. Thanks. It was all for today. We'll join tomorrow again and make some other parts of the landing gear.
Thank you, sir. Thank you.